Hey, welcome back to an Oxford Mathematics Submission Test, October 30, 2019. So the fresh one. So here I want to consider type H question. This is about right angle triangle. So it's right angle at B. So we have right angle triangle, alright. And we mark vertices A, so B and C. So we also know that sides, lengths, are positive numbers in geometric progression. So, okay, what we can write? We can mark sides as C, the side opposed to 90 degrees angle. It's a hype. We also can mark and B correspondingly. So, and we need to figure out BAC, angle BAC. So that's why it's here. We specify it's here. Let's say this alpha, and we want to figure out tangent of this angle. So the main question is to find tangent alpha. Okay, so just go by definition. So tangent is A over B. So because sides are in geometric series, in geometric progression, or in geometric sequence, we can write the following. So because C is the biggest side and the longest side, and both A, B, C lenses, so hence they're positive, this condition for sides, we can write the following. So C is more than A, and C is also more than B. So there are two options. So option 1, we have A, B, and C as geometric series or geometric sequence. In this case, we don't need to sum up, so we consider it geometric sequence. And because this geometric, we can consider as the common ratio. So each next term is the previous multiplied by r. So we can write and set up the set of equations through r. Okay, so we have A, we have B is just simply r times A, and C is simply r squared times A. So their sides A, B, and C correspondingly. Okay, that's the first option. This is the order, increase in order. And we figure out how they connected through common ratio. Okay, so what we're gonna do now, we can set up Pythagoras. So using Pythagoras theorem, we can connect C and two of the legs as the following. And just simply we can plug all the values that we figure out, all the expression for A, B, and C in this equation. Okay, let's plug it, and we'll have R4A squared. I just transfer all to the left side. So A squared, simply A squared, and minus also B squared. In this case, is going to be R squared, A squared equals 0. So, because A is non-zero value, we can either factorize or just simply cancel by division, and finally we'll get the following. R squared squared, that's for simplicity and to have the right structure, minus r squared and minus 1. That's what we have. Okay, and this is the right time to solve this equation. So let's put the value r squared. It's basically biquadratic, so we can change t as r squared. So we can write t squared minus t minus 1 equals 0, and just find t, but I mentally try to find r squared instead of t. So r squared is minus 1. I just use the formula, quadratic formula for r squared. Okay, I don't specify that, I hope you know. So it's minus 1 minus minus 1 plus minus square root of discriminants. In this case, discriminants 1 minus minus 4, so it means 1 plus 4 is 5, so square root of 5 and over 2. Okay guys, so you understand that r squared should be positive, and when subtracting square root of 5 we'll get negative result, so the only value that's possible here is 1 plus square root of 5 over 2. And now we're just taking the square root of both parts. So normally you should write plus or minus, but I just reject negative value because our common ratio should be positive because all lengths are positive. So finally we'll get this expression for the common ratio. So okay, we've got our common ratio, and basically what we have all sides. So our primary goal is to figure out tangent. If we marked tangent, if we mark sides according to this figure, so B is the adjacent side, A is the opposite, so tangent alpha is A over B, and let's finally combine with the common ratio that we found. So I just rewrite common ratio right here is 1 plus square root of 5 and over 2, and square root of that according to what we found recently. So this is R, and we also know that A is just A and B is R times A. So finally tangent alpha will be the following: A over AR, so means 1 over R because A was cancelled. So that's why one option for a tangent alpha to be 1 over, so we can swap simply what we have here and just separate the bottom part and the top part of the fraction. So right now we have this because 1 over R is basically an inverse fraction, and from there we can write the tangent alpha is, let's multiply. So remember how we cope with surds, we just multiply by the conjugated expression. So here I'll do the same, so we multiply by conjugated. Conjugated means the same structure in terms of binomial expression, but with the opposite sign, and multiply the top by the same. Okay, so finally we'll get the following. So we'll get fraction 1 square root 1. Okay, yeah, we're not supposed to multiply by that because it's negative on the square root, so we multiply by reverse, means square root of 5 minus 1 and square root of 5 minus 1 as well. So finally what we'll get 5 minus 1 in the bottom part, and in the top we'll get square root of 2 and times square root of 5 minus 1. That's what we'll have right now. And let's simplify a little bit. So we've got square root of 4 in the bottom part, here, so we'll get square root of 4 is 2, and we simply can cancel square root of 2 and 2 in the bottom part, leaving square root of 2 in the bottom part. Okay, and on the right, so on the top part, we'll have this. So this is one expression for tangent alpha. So amongst the choice, we need to have square root of 5 minus 1 over 2. That's one option. So actually, we can actually stop, but I consider how to get the other solution, because obviously we found the choice C to be correct. So choice A is incorrect because the expression that we have here, 1 minus square root of 5 over 2, is simply has a negative expression under the square root. It means here. So that's why we're not eligible to have that. But how to get the second solution in the form square root 1 plus square root of 5 and over 2. So let's see indeed. We marked sides as A and B becomes adjacent. But we don't know whether A is bigger than B or vice versa. So that's why in this case, if we swap geometric progression or geometric sequence so that the first, in terms of the length, B goes, we basically swap them, we can have the following. We can have the other option. So it might be B side and this might be A side if A is bigger than B. So hence we have tangent alpha to be A over B, or in this case tangent alpha will be R. So the other option, because we wrote only the first option, so the second option for a tangent is simply tangent alpha is also possible to be A over B, and in this case when B is less than A, we'll have just equals to R. And what we found recently, this is the second option, just to have tangent alpha as square root of 1 plus square root of 5 and over 2. That's how we can get both options. So the right choice here in each task is C. So hope you enjoyed, and we'll be discovering other types of questions. See you.